Everyone, in this section we're going to look at the trigonometric ratios of acute angles, and you should remember acute means less than 90 degrees. Okay, so this is our triangle. Let's read through. When working in a right angle triangle, the longest side is known as the hypotenuse. The other two sides are known as the opposite and the adjacent. The adjacent is the side next to a marked angle, and the opposite side is opposite this angle. So if we have the right angle here, the side which is opposite the right angle is called the hypotenuse. The angle you're interested in here, that's called theta. That symbol is the Greek symbol theta, T-H-E-T-A. And we often use that for angles. The angle opposite that is called the opposite side. That's here. The other side is called the adjacent side. Now, the three ratios we're interested in here is the sine, cosine, and tangent ratio. Sine, S-I-N-E, the short is S-I-N, not sin, sine. Cos is cosine, tan is tangent. Okay, and these are fractions, these are just ratios of side. So the sine of the angle is the ratio of the opposite side to the hypotenuse, and the same for the cos and the tan. The quickest way to remember these is SOHO, or S-O-H for sine, cos is car, C-A-H, tan is toa, T-O-A. And those are the easiest way to remember those, and we'll look at them in a minute. Okay, in this example we have a right triangle, and it's called ABC, and we want to know which sides are the hypotenuse, the adjacent, and the opposite. So look at your angle. This must be the opposite side. This is your right angle, so this must be the hypotenuse, and the other side must be the adjacent side, the remaining side, A. So the hypotenuse is BC. You could write CB, but normally we put the first letter first. The adjacent is AB, and the opposite side is AC. So that's how you define each side. In this example, we want to write down the values of sine, cos, and tan for the following triangle. So let's remember sine is S-O-H, cos is car, C-A-H, tan is toa, T-O-A. Okay, so sine of the angle is opposite on hypotenuse, 8 on 10, which is the same as 4 on 5. Cos of the angle is car, C-A-H, 6 on 10, which is 3 on 5. Tan of the angle, toa, T, opposite, adjacent, 8 on 6, which is 4 on 3. Okay, in example 3, we want to label hypotenuse, adjacent, and the opposite of each triangle. So let's write the hypotenuse here. Hypotenuse is opposite the right angle. So this one here will be BC. How about hypotenuse for this one? Hypotenuse will be DF. And hypotenuse here, opposite the right angle, GI. Okay, so how about the opposite side? Opposite the angle. Opposite, so it will be AB. Opposite the angle, EF. Opposite the angle, HI. And the adjacent side, adjacent to the angle here, AC. Adjacent to the angle will be DE. And adjacent to the angle here will be GH. Okay, so that's how you label the angles, or label the sides rather. In this example, we want to label each triangle with sine, cos and tan as fractions. So looking at the first diagram, we have sine theta, and we know sine is opposite on hypotenuse, so 3 on 5. Cos theta is car, adjacent on hypotenuse, 4 on 5. Tan theta is opposite on adjacent, okay, 3 on 4. This diagram, sine theta is opposite on hypotenuse, 5 on 13. Cos theta, car, adjacent on the hypotenuse, 12 on 13. And tan theta, tan is opposite on adjacent, 5 on 12. Okay, in this diagram, you can try this yourself. Okay, just wait. Would you like to try it? Pause the video. Okay, so we have sine theta. Sine is opposite on hypotenuse, 15 on 17. Cos theta is adjacent on hypotenuse, 8 on 17. And tan theta, tan is opposite on adjacent, 15 on 8. Okay, in this example, you'll need to get your calculator and you can check my working. Okay, we want to find the sine of 30 degrees. Just put that into your calculator and just check you get a half. Okay, cos 66 will be a decimal, and check it, you should get 0.407. And I just write to 3 decimal places. And tan 37 is 0.754. In part B, we do something similar, but we need to find the angle. So what you need to learn how to do is use the inverse function. So if cos theta equals a half, let's call this the first one, cos theta equals a half, you need to find the inverse of cos. So look on your calculator, the angle should be equal to the cos inverse function of a half. If you do that calculation, you should find that the angle is 60 degrees. Okay, so look for this button on your calculator. Put the ratio into here and you'll find the angle. Part 2, the angle will be sine inverse of 1. And if you do that, you should get 90 degrees. And part 3, tan theta, which is 2. If we do the inverse, tan inverse of 2, we'll get the angle. And if you do that, you should get 63.4 degrees for that one.